Hi everyone, today we are going to go through 5i or 6i, the sine rule and the area formula, okay? So first thing first, we are going to go through sine rule here. Some of you probably remember we have done it in year 9 and 10. You guys probably remember the equation of a over, a over sine A equals to B over sine B. Okay, so remember the equation, you probably can't really use it much, but there's a rule of thumb here. If you know a angle and the opposite side, that is a good sign of it. And then if you know another angle, so if you know B, you can use B and you want to find the opposite side of B, which is little b here. You can use the sine rule using this one. Now, if you know if you don't know angle B but you know angle C, you can still find it because B is basically 180. Wait, I'm just right here. B is basically just 180 degrees minus angle A and minus angle C. Yeah, so if you know one angle, you can find the other. So if you have one pair, that's good. That's a good sign. And if you know another angle, you can basically find all the signs. Okay, I'm going to give you one example here. Question 1 is way too easy. Basically, just substitute into the equation. Question 2, you actually need to do a little bit more. That's why I give you an example for question 2. Now, again, as I said earlier, if you know one pair, then you set. But in this case, you actually don't know a pair. But you know two angles. Obviously, you can find the last one, which is using the angle sum, which is 180 minus the other two angle. You realize that the last angle is 50 degrees. Now, if knowing this is 50 degrees, you got one pair. Okay, so as long as you know one pair, you can find any other side you want. So in this case, you're looking for the side that is opposite 70 degrees, which we can just substitute into the equation. We can find it out as well. So let's do that part. So first of all, if you look for sine, if you look for a side, we put for a side on top. So let's do the known pair first. So 12 over the angle is 50, so sine 50. And then the other one's the unknown A over the angle is 70, so sine 70. Okay. Let's times both sides by sine 70. So you got 12 sine 70 degrees over sine 50 degrees equals A. So typing calculator, you can work out what A is. Make sure it's in degree mode, yeah? So 12 sine 70 over sine 50. Okay, so my answer is 14.7201. We are in the 2 decimal place, will be 14.72. Okay, so that's pretty straightforward. Let's move on to finding unknown angle. It's basically the same. So again, you need one pair of known side and angle. Then if you know one of the sides, you can find the opposite angle of it. Okay, so if you know B, you can find angle B, no problem. Once you find angle B, you can find angle C as well. So yeah, that's that. Okay, so I give you one example here. This one's also illustrates a ambiguous situation. When we find angles using sine rule, we actually need to find two angles. So I give you an example here. So in both of the triangle here, fit the criteria of the question. So we got a known side of 9 centimeter, a 5 centimeter, both same, yeah. The angle opposite of the 5 centimeter, so 5 centimeter is 22 degrees. So this one is 22, this one's also 22. Both fit the criteria, but they are different angles. They're different triangles. Okay, so one of the 5 centimeters kind of swing inward, the other one kind of swing outward. When we look for the angle opposite of 9, so we have a obtuse angle here and a acute angle here. So we basically need to look for both of the angles. Okay. The reason being that is that if you remember, we got all station to central. Okay, so sine a obtuse angle, it remain as the same as sine a acute angle. That's why we got two. If I may show you what it look like here. If you remember, if these two are both theta, they got the same sine ratio. Okay, be opposite are positive and hypotenuse are the radius. Okay, so that's why we got two situations here, and every single time we need to work when we need to use sine rule to find an angle, we need to provide two angles. Okay, so you may be curious how to find the obtuse angle here. The obtuse angle will be 180 minus the angle that we find. So let's give it a go. Okay, so again, if angle on top, so if angles are known, we put angle on top. So we do the known angle first. So sine 22 degrees. Oopsie. Over opposite, that is 5, and then we do the sine theta, the unknown angle, and over 9. Okay, so we times 9 both sides, so we've got sine theta equals to 9 sine 22 degrees over 5. Okay, so theta we can do inverse sine, so shift sine in your calculator. Yeah, so then we can work out using calculator. So shift sine, make sure it's in degree mode again. So 9 sine 22 over 5. So I got 42.39 degrees, and we run to nearest degree, so it's 42 degrees. Okay, so 42 degrees. Now that is the acute angle. The obtuse angle will be 180 minus 42. So 180 minus 42 is 138 degrees. So both, we need to know both of angles. Okay, it's really important you do both, otherwise you're not going to get 4 mark for a question like that. Okay, next is the area formula. The area formula is really similar to the area formula for a right angle triangle. I'm going to show you how. Okay, okay. Right, so I got a right angle triangle here. The one next to it will be height and the base here. Right, so let's say this is just any triangle. We can use exactly the same one to work that out. So area formula is half times A times B sine C. Okay, so AB are the two sides next to the angle. I'm going to highlight it. So AB are the two sides next to the angle. Okay, and if we know the two sides and the angle in the middle, we can use the area formula. Okay, in this case it's basically the same. So we got the two sides and the angle in the middle, so we can use the area equation, so area formula. So in this case we just substitute in. So one of the sides is H, the other side is B, and then sine the angle is 90 degrees. Okay, now 90 degree happened to be 1. Sine 90 happened to be 1. So basically the same as half times height times base. The equation for right angle triangle. Easier. So for other that's why for right angle triangle we don't actually write sine 90 because it's actually 1. So for right angle triangle the area of sine is half times base times height. Okay, so for those non-right angle triangles we just need to substitute in this area formula. So area here equals to half times A, which is 3 here, times 4, and then sine 50 degrees. Okay, so we just need to put in calculator. Because we ran to nearest centimeter, the answer is 5 cubic centimeter, square centimeter. Don't get it wrong. Okay, so the next two should be quite easy and simple, so I'm not going to go through that. Let's go through a little bit harder question. What if you know the area and we need to find one of the sides? Well, write equation first. So we just need to substitute in. So 48 equals to half times 12x sine 30. Okay, so I happen to know that sine 30 is half. Well, you should know already the absolute value. So that would be half times half is a quarter times 12 is 3. So we got 3x, x is 16 meter. Okay, so that's quite simple. What's the question? This exercise are simple, so I'm not going to go too far into that. Here's your homework. Now, I'm for those who are doing 3 unit, or for those one who are more like excited about learning, I'm going to do a separate video on how to prove this. This formula here is basically the combined angle formula. For those who are doing 3 unit, we'll be doing these later on. So I think it's good exercise for us to go through on the proof. So we're going to go through that in a separate video. Okay, so stay tuned and I'll upload that video soon. Thanks for watching.